Well, hello there. I'm Gemini. That battery can last up to 24 hours even with the always-on display turned on. It's pretty cool.
Welcome. Today, we're going to take a deep dive into a foundational tool in management accounting, standard costing and variance analysis. We'll be exploring how organizations set these crucial benchmarks for performance and, maybe more importantly, how they analyze and respond when actual results don't quite match the plan.
So here's our roadmap. We'll build this framework from the ground up, starting with the fundamental purpose of standards. Then we'll get into the mechanics of how you actually set them. From there, we'll dive into the core of the analysis, deconstructing variances from materials, labor, and overhead. And finally, we'll tie it all together to see how this information drives managerial action.
All right, let's begin with the most fundamental question. Why bother? Why do companies invest so much time and effort to determine what a product or service should cost long before it's ever produced? What is the real purpose here?
Well, at its very heart, a standard cost is a carefully engineered, forward-looking target. It is a predetermined cost for a single unit, representing what that unit should cost under efficient yet achievable operating conditions. It's not just a guess or a historical average, it's a benchmark, a gold standard, against which we measure actual performance.
Now, this is a distinction that's absolutely critical to understand. People often use standard and budget interchangeably, but they are fundamentally different in scope. A standard is all about a single unit, the cost per kilogram, the hours per part. A budget, on the other hand, is a total amount. It's the total expected cost for an entire period. You can think of the standard as the essential building block that you use to construct the overall budget.
So why go through all this effort? Well, the strategic advantages are quite substantial. Standard costs are invaluable for planning and for setting selling prices. They also help instill a culture of cost consciousness throughout the organization. But, as we'll see, one of their most powerful benefits is enabling what we call management by exception. And they even make the day-to-day accounting work, like costing inventory, a whole lot simpler.
Okay, so we've established the why. Now let's get into the mechanics, the how. How does a company go about constructing these building blocks of cost management with any degree of precision?
You know, when you're setting standards, you have to make a choice about how rigorous they should be. On one end, you have ideal standards. These assume absolute perfection. No waste, no machine downtime, no human error. They're almost impossible to attain and can often demotivate employees. That's why most companies use normal standards. These are still challenging, but they're attainable. They represent efficient performance under expected conditions with realistic allowances for things like normal machine maintenance or employee breaks.
Building the total standard cost is a systematic process. It's not just one number pulled out of thin air. As you can see, we have to establish standards for each key component. For direct materials, we need both a standard for the price we pay and a standard for the quantity we use. The same goes for direct labor. We need a standard pay rate and a standard number of hours. And finally, we develop a predetermined standard rate for manufacturing overhead. And remember, this is a collaborative process, requiring input from purchasing, engineering, production, and HR to get it right.
So it all comes together in this simple formula. The final total standard cost for one unit of our product is the sum of these three meticulously calculated components. This total becomes our ultimate benchmark. Now, the real world is never this perfect, so what happens when our actual costs don't quite match up?
And that brings us to the analytical heart of this whole system, variance analysis. This is where we deconstruct the difference between standard and actual. Let's begin with our first major cost component, direct materials.
This question gets to the core of the analytical challenge. Let's say your actual material cost was higher than the standard. Well, what does that really tell you? Not much on its own. Was it because you paid more per pound for the material than you planned? Or was it because your production team was inefficient and used more material than the standard allowed? A total variance just tells you that there's a problem. It doesn't tell you why. We need to isolate these two effects.
And this three-column matrix is the elegant tool we use to do just that. Let's walk through an example. Imagine our standard is to use 2 kilograms of material at a standard price of $10 per kilogram. Our standard cost then is $20. Now let's say what actually happened was we used 2.1 kilograms and paid an actual price of $11 per kilogram. Column 1 on the far left shows our actual cost, actual quantity times actual price, or 2.1 kilograms times $11, which equals $23.10. Column 3 on the far right is our benchmark, what we should have spent. standard quantity times standard price, or 2 kilograms times $10, which is $20. The total variance is just the difference between the two ends, $3.10, and it's unfavorable. But here's the genius of the middle column. Here we calculate actual quantity times standard price. So that's 2.1 kilograms times our standard of $10, which equals $21. Now we can isolate the variances. The difference between column 1 and column 2 is the materials price variance. It's a $1.10 unfavorable variance, and it's purely because we paid $1 more per kilogram than the standard. The difference between column 2 and column 3 is the materials quantity variance. It's a $2 unfavorable variance purely because we used an extra 0.1 kilograms of material. See how that works? We've pinpointed exactly where the problem lies.
So once we've calculated these variances, who's held accountable? Well, that's the key. The price variance typically falls under the responsibility of the purchasing department. Maybe they bought a higher quality material, or perhaps they failed to secure a volume discount. The quantity variance, on the other hand, usually falls to the production department. It's a measure of efficiency. Was it caused by inexperienced workers, faulty equipment, or perhaps just carelessness?
Now, the really powerful thing about this analytical logic is that it's not a one-trick pony. We can take this exact same framework of isolating price and quantity effects and apply it directly to our other major manufacturing costs, direct labor and overhead.
Look familiar? It's the exact same structure. We just swap price for rate and quantity for hours. Let's try another example. Say our standard is 4 hours of labor at a standard rate of $20 an hour, making the standard cost $80. But in reality, our workers were very efficient and only took 3.8 hours. But we had to use more senior staff, paying them an actual rate of $21 per hour. Column 1, our actual cost, is 3.8 hours times $21, which is $79.80. Column 3, our standard cost, is 4 hours times $20, which is $80. So our total labor variance is $0.2 favorable. But that number hides the real story. Let's look at the middle column, actual hours times standard rate. That's 3.8 hours times $20, which gives us $76. Now compare columns 1 and 2. That difference is a $3.80 unfavorable rate variance because we paid more per hour, but comparing columns 2 and 3 shows a $4.00 favorable efficiency variance because our workers were faster than the standard. The combination of those two gives us that small net favorable variance.
And again, the causes and responsibilities are analogous. That labor rate variance might be caused by using more highly paid workers on a job than planned. The efficiency variance, once again, is typically the production department's responsibility and could be traced to things like the quality of worker training, employee fatigue, or even the condition of the machinery.
All right, manufacturing overhead gets a little more complex because we need to separate it into its variable and fixed components. For variable overhead, we have a spending variance, which is a price type variance. It tells us if we spent more or less than expected for the hours we actually worked. But look closely at the efficiency variance. Its formula is driven by the difference between actual hours and standard hours. This makes perfect sense, doesn't it? If your workers take longer than the standard, you're naturally going to consume more variable overhead, like the electricity running the machines.
Now, for fixed overhead, we introduce a really interesting new idea, the volume variance. The spending variance is straightforward. Did we spend more or less on fixed costs, like rent or insurance, than we budgeted? But the volume variance is different. It's all about capacity utilization. Think of it this way. Your factory rent is fixed. If you plan to produce 10,000 units, you're spreading that rent cost across all those units. If you only manage to produce 8,000 units, you haven't used your factory as well as you planned. This underutilization results in an unfavorable volume variance.
So, we've done all of this detailed analysis. We have our price variances, quantity variances, spending and volume variances. What's the point? This final section is about closing the loop, translating all this analysis into meaningful managerial action.
The entire purpose of this system really boils down to this single, powerful principle: management by exception. A manager's time and attention are their most limited resources. Instead of drowning in data about every single operation, variance reports act like a spotlight, highlighting only those areas where performance is significantly different from the plan, both good and bad, so that's where they can focus their energy.
But what does significant actually mean? Well, that's a judgment call for management to make. They have to set a threshold for investigation. It might be an absolute dollar amount, like investigating any variance over $1,000. Or it could be a relative amount, like flagging any variance that's more than, say, 10% of the standard cost. The goal is to filter out the minor everyday fluctuations and concentrate on the deviations that truly matter. And this brings us to our final and perhaps most critical point of reflection. The word favorable sounds inherently good, doesn't it? But is it always? Let's imagine a purchasing manager achieves a massive favorable price variance by sourcing cheaper, lower quality material. On paper, that's a huge win for the purchasing department. But what if that cheap material constantly jams the machines in production, causing significant waste and downtime? That would create a massive unfavorable quantity variance for the production department. This shows us that these variances are often interconnected. A win in one department can easily cause a loss in another. A holistic, big-picture view is absolutely essential, and that's the thought I'd like to leave you with.